Video problem 27. This is dealing with molar mass. Let's see what we got to do here. So first of all, you'll need a periodic table. So here's my periodic table. All right. Determine the molar mass of the following compounds. We have nitrogen trichloride. So this is all pretty easy stuff that you're going to find that it's super simple. So what you do, so here's nitrogen. Let's take a look at the periodic table. And what we're looking for is the molar mass of nitrogen. So right down here is the molar mass of nitrogen. Do not round anything. Okay. So nitrogen is 14.01. All right. We've got 3 chlorine. So each chlorine, and we'll talk about units here in a second. Each chlorine, there's chlorine right there. Each chlorine weighs 35.45. So I'm going to take 35.45 and I'm going to multiply by 3. Okay. And so I'm going to get my total answer here. I got, let's see, 14.1 or 14.01, pardon me, plus 3 times 35.45. So I get a value of 120.36. Let's talk about units. The units are grams per 1 mole. Okay, so that's how much 1 mole of that compound weighs, 120.36 grams. Take a look at barium nitrate. Same deal. I've got 1 barium, so let's see, where's barium? Right here, 137.3 for barium. I've got 2 nitrogens, so that's 14.01 times 2. We already have that one. Then I got 3 times 2, which is 6 oxygens. So that's 16 times 6. And then I just add them all up. So it's 137.3. Be careful of order of operations. So we get a value of 261.32, and that's grams per 1 mole. And now let's do this one. This is what's called a hydrate. So a hydrate is basically a ionic compound that's surrounded by a certain number of waters. Okay, so in this case it happens to be 12 waters. This is potassium aluminum sulfate, dodecahydrate. Dodeca is 12. Okay, so let's see how we do this one. We've got potassium. Right, so let's see what potassium is. 39.10. I've got 1 aluminum, which aluminum is 26.98. I have 2 sulfurs. Each sulfur is 32.06. Then I've got 8 oxygens. Each oxygen is 16.00. Right. So I have that. And then I have 12 of these waters, and I just add them. I know that looks like a multiplication symbol, but that's the symbol to show that it's a hydrate, that it's surrounded by waters. So I'm going to take 12 times H2O, which would be 12 times, I don't want to confuse you too much. Let's do water over here by itself. Okay? So here's water. We've got 2 times hydrogen, which is 1.008. Let me make sure that's what it is. 1.008 times 2. And then I've got the 1 oxygen, which is 16. Okay, so let's add these up separate here. For the potassium aluminum sulfate, I got 39.10 plus 26.98 plus 32.06 times 2 plus 16 times 8. So for this, I've got 258.2. Then I'm going to add that to the waters, which is 18.06, but I've got 12 of those, right? So I got 12 times that value. So I'm going to do 18.016 times 12, which is 216.192. I'm going to add these two together. So I get a value of, with sig figs, 474.40. That's how many grams are in 1 mole of potassium aluminum sulfate dodecahydrate.